Okay, welcome back. So in this lecture we're going to learn a little bit about messaging and why it's important for the tools that you develop. So messaging allows us to provide information back to the user or feedback back to the user. So this way they are not left wondering what's happening. You can give them specific feedback as your tool is executing that indicate the progress. So we are 25% done, we are 50% done. The other thing we can do is we can give them meaningful error messages as well as meaningful status messages about how the processing is going. And if there's an error, you can specify what the error is, so that way your users aren't stuck with the error 99999 999999. An exception occurred. So you've probably seen that from Esri, which is their generic some error occurred thing. So that's probably been one of the things which has annoyed you the most of using their tools. So when we write our tools, we're going to do a better job of providing helpful error messages and error codes that inform the user what went wrong and why, rather than just something went wrong without any instructions about how to fix the problem. So we're going to start with the toolbox we made, which does proximity search around a building. So this is the original tool here, right? So it's got a def init inside of the toolbox class, arcpy, import arcpy at the top, like everything. Inside of the init for the toolbox class is where we set the label, the alias, and then the list of tools that are inside of this one. And then we have the class definition for our actual tool. So building proximity is second class name. It's in the list of ones that are included inside of this toolbox. Now inside of the building proximity class, we have an init as well, with some information about it. So what category is in, running in background, always false. That's only used in ArcMap. Description and label. Then we have all of the parameters that are associated with this tool. So this one has two, one which is called building number and one which is called buffer radius. Buffer radius is a floating point number. Building number is a string. They're both required. Parameter 1 has a filter that enforces that whatever the user enters has to be between 10 and 100. Then we have is licensed, and if you recall, this was where you would check for any licenses that were required. Update parameters. This is where we can mess around with the value of other parameters before after one is set. So using the value of one parameter, we can change the display or the values of other ones. And then finally, update message, which is the one that we're going to be playing with, which is where we give error messages, and then execute, which is what actually does all of our stuff. So if we remember what it does, we set the building, or set the geodatabase we're working in. We convert the two inputs that the users gave us, the building number and building input size. Building input size gets turned into an integer. Building number input stays just as a text. Then we go through and we check to make sure that the building exists. So to do that, we are going to build our where clause. So our where clause is where building equals the value that the user has entered. We're using string formatting here, so the %s gets replaced with whatever is after the % symbol. Then we do a search cursor, where we're searching inside of structures using a where clause. So it's where building equals 0443, for example, for the O&M building on campus. And then we loop through the results that come back from the cursor, and if the building attribute is associated with the one that we asked for is in there, then we keep our should proceed flag equal to false. So this is basically, were we able to find the building that the user wanted to buffer, and if so, then we go through and we buffer the building. So one of the things you might want to do is do that checking, does the building that the user asked for exist, on tool validation. So on tool validation means when the user enters a value in one of the input boxes, as soon as they move away to another one or click enter, then that input parameter gets validated. So what we can do in validation is we can pop up an error message immediately and tell the user whatever you just entered is not valid. So you might be doing this for input files if a file already exists and you're about to overwrite it, or if you're checking the existence of a file before you let the user proceed, you might pop up an error message that says file does not exist, or you might pop up, just like a filter does, something telling the user that they gave an invalid value. So the way that we can do that is we can take the logic for checking that the user input is valid and move it into the update message section of our tool definition. So remember that update message is one of the functions that is inside of the building proximity class. Building proximity class is our tool class. So this update message gets called when the user moves away from the particular input field they're on by either clicking somewhere else on the map, or clicking somewhere else on the input form, or clicking somewhere else on one of the input fields of the input form. So as soon as that occurs and there's a value in an input parameter that the user has now clicked away from, that value can be validated inside of the update message portion. So originally the update message portion just does nothing and just returns. We can modify this to put our specific logic in there. So let's look how we do that. So remember that each of the parameters of our tool is now in a list. We added them inside of get parameter infos. So in all of the other places, those are now accessible. So what we have to do is, if we're interested in a particular input field that we want to use for checking, then we have to loop through each of the input parameters until we find the one that we're interested in. So how do we do a loop? We do for thing in a list. So for new variable, we are naming parameter in our list of parameters. If the parameter's name equals building number, then do something, because building number is the one that we are looking at, or looking for, and that is defined by the name value that we assign with our new arcpy parameters when we create each of the parameters up inside of get parameter infos. So get parameter info has an attribute called name, which we're setting equal to building number, and then we can use that down below to say if parameter.name equals building number, then do something. Cool. So parameters have names, they have values, and what we can do is we can set the value, or we can get the value of what we're interested in, put it into our own variable. So parameter.value will give us the value of what the user entered. We're assigning that into a variable named building number. Then we're setting up the location of our Geog database. We're building our where clause, and then we're applying our search cursor to check to see if that where clause matches any buildings inside of the structures database. So at that point, we can now do something with the result. What we're going to do with the result is check to see if it's greater than 1, or if it came back with at least one building. If it came back with at least one building, then we know that the building number the person entered is correct, and we should keep going. So there's lots of different ways to check to see if a building exists. This is just one of them, what we're looking at here. So we have run our search cursor, and it has come back with something. And remember that search characters have loops. So we can loop through it, and as soon as we go through the first time, then we know we have a row in there, and we should allow the user to proceed. Right, so one way to do that is keep a counter variable and then just do the simplest loop ever, which is for each row in cursor, if you get in here, meaning if there are any rows in the cursor, increment our counter by 1. So that'll just loop. If that building came back more than once, this value is going to be higher than 1 because it's going to increment each time by 1 for each of the buildings that are in the result coming back. So we don't care. We only care if it's 1 or more. Right. So then once that is finished, if our count is still 0, it means that it never made it into this inner loop here, which means that the cursor never had any rows in it, which means that that building doesn't exist. So if our count remains 0, set an error message for that parameter, which is can't find the building, whatever the user entered in the structures layer, passing in through string formatting the building number, which was the value. So boom, with that, when a user types a value in here and they move away by either clicking enter or clicking somewhere else on this on the input form or clicking into a different input field, the update parameters function is going to get called. So we loop through all of the parameters, and we're going to mess with the building parameter, or building number parameter in this case. So if we got our hands on the parameter, because there's 2 parameters, there's building number and buffer radius, so we need to check that we're working with building number. So when we roll on to the building number 1, going to get its value, going to search through the database to see if it exists. We're going to keep track if it exists by looping through all the results with a counter variable, incrementing the counter each time there's a row. If there are no rows to loop through, then we set an error message. And that's how you get this little pop-up right here. So this is a more useful error message than 999999, an error has occurred. So notice that the number here is 000001. We can make a dictionary of what error messages are for our program, and then if you have an online help, you can make this a link which automatically goes to your help information that your user can use to then fix whatever the problem is. So this is how you can do it. This is sort of a clunky way of checking to see that something exists. We could have used select by attribute instead. There's 20 different ways to do everything in programming, so this is one, but hopefully gets the point across that if you want to validate your parameters more than you can do with just a filter, this is where and how you would do that. So inside of the update messages, you can go through and do any kind of validation that you would like, and then if you would like to indicate to your user as well as occupier that there's an error and not let your tool run, you just do param.setError with some kind of meaningful error message and error number that your user will be able to go and get some help for. Cool. So that's the first half. You have probably seen as you are running a tool that some messages get printed out from time to time in the tools that you run. So those are one form of debugging, in that you are just writing out to the user how far the system got and what it's currently up to. So that way you as the programmer can see that your system is reaching specific specific portions of the code. So if you didn't know where something was failing, you would at least know it got this far. So these are helpful messages because it provides feedback to the user that things are actually happening, which is much nicer than just when they hit the run button, it just sits there and they don't know if it's actually running or if it's actually broken, and they have no idea how long it's going to take or anything like that. So you can add messages which get printed out in the script output. Used to be called the results panel in ArcMap. Now it's just part of the tool. It's probably still in somewhere in some kind of results. So we can print those out, and then we can also add a progress bar. So what does a progress bar do? It allows the user to see that they're 25% done, or 75% done, or 100% done. So without a progress bar, you just get the little blue thing that just goes back and forth constantly, and you have no idea. That's the default one, and that just shows, like, by indicating that a little blue line is moving, that your tool is still running. For long-running processes, sometimes it's nicer to have a progress bar that shows you the actual percentage of the way done, and this is something that you can know in advance, because if you have 100 files to loop through, or if you have a directory with some number of files, let me just check we're still recording. Yes. If you have a directory, you can know how many files there are just by doing the length of the array of strings that came back when you did list directory contents. So you know the maximum number there are, if there's 100, for example. And then each time you go through a loop, you know where you are in that loop. You know if you're in the first iteration or second. So if you're 1% done, or 2% done, or 3% done. So you can provide the user meaningful feedback, which is a nice little gift you can give to them, rather than just having your code sit there and they have no idea how long they're going to be sitting there, how long things are going to take. You can provide them with meaningful feedback that allows them to have more confidence in your tool. So that can be through the form of progress bar like this, or it can be through setting messages that tell the user what's happening. So both of them are real simple, so we're just going to look at those. So for adding a message, all you do is arcpy.addMessage and the thing you want to write. All right, and then it prints it out just like that. So as you go through certain parts of your code, it's not a bad idea to put some output messages so that the user can see, or if they need to report to you, it failed after validating building number once more. All right, so then you can say, oh, so that means you didn't enter a valid building number if it never got to the next step, because I was expecting to see buffering next, and if it never got to buffering, it failed right there. So you can actually add output error message to this window through arcpy.addMessage or arcpy.addError. So there's a lot of ways you can provide feedback to the user, and they are all very, very helpful and provide a better user experience for the person who's trying to use your tool. So adding a message is super easy. You just do arcpy.addMessage, and whatever you tell it to add is going to get printed out in the script result pane. Progressor, the default progressor, you don't have to do anything. It's automatically just going to go vroom, 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 back and forth. Doesn't tell the user anything about how long it's going to take for this thing to go. So if we use a step progressor, then it gives them a percentage completed, so that way they know. So how do we make a step progressor? So we have to have a start value, which is the bottom number of the progress bar, and a maximum, which is the top number of the progress bar. Then we have two other things which are just helpers in here, variables that we set. So one is read time and one is step. So in our particular case, we're just going to increment the progress bar by a quarter each time that we call update progress. And each time that we call update progress, it's going to go from 0% to 25%, from 25% to 50%, from 50% to 100%. So ours only has 4 values because this is just a demo. The read time is a little thing we're putting in there where we make our tool pause, so that way the message on the progress bar can be shown to the user, because otherwise it just disappears automatically. So it's kind of hacky, but it's one way to get around the fact that the progress label disappears really quickly, because our tool runs really fast. So if our tool is not running so fast, this thing can stick around a little bit longer. So we have these 4 variables that we've created. The bottom value of the progress bar, the top value of the progress bar, the step that we're going to go through each time we update the progress bar, and how long we're going to wait to show the message to the user. So setting up the progress bar is pretty simple. We just do arcpy.setProgressor. We tell it the type that we want, so we want a step 1. Then we pass in the first message, and then we pass in the lowest value, 0. We pass in the highest value, 100. This is how it knows what percentage it's at. And then we pass in the step of how much it's supposed to increment each time. So with this, it's all set up, so our progress bar goes from 0 to 100, knowing that it goes by steps of 25. So when we want to set its position, so when we want to inform the user that something has happened, we just do set progressor position, and then we give it the value between our start and maximum where we want it to be. Right, so we give it start plus step equals 25, but since we go from 0 to 100, there's actually 101 items in there. So we have 0, 1, 2, 3, 4, 5, all the way up to 99, 100. So we have 1 through 100 plus 0. So we have 101. That's why the first time that we call it, it gets set to 26, because we did 0 plus 25 is the 26th position. So you can give it a hard-coded number, like we're at 1%, 2%, 3%, or you can have this done computationally, where you have a loop of 100 things, and where you are at in the progress is on the iteration. So you keep a counter variable, then you pass that counter variable in. So we set the position of where we want it to be. That automatically fills in the percent that it's at. Then we set the label that we would like to be shown above it. Then we make our code pause. So making your code pause is not usually a really good thing to do because there's no other processing that's happening. If you did want to pause, you can do time.sleep with some kind of length, and ours is going to sleep for 1.5 seconds, so that way it gives us long enough to read it, because you may have seen these things whipping past. So if you have the output messages that are keeping track of what's happening, it's not super necessary to have this thing remain there, because as soon as you do the next update, this current message is going to go away. So that's how you do it. Eventually we get up to 100, and when it's at the maximum value, then this says 100% complete. And when the tool finishes, it automatically goes over to the 100% complete. So this is how you can add a bit of user feedback, which makes people feel a lot better about your code and your plugin which they're using, because you give them interesting feedback, you give them helpful error messages when they do something wrong immediately as soon as they do that thing wrong. So if they enter an invalid input, they automatically get told that they have an invalid input. So it's not like the tool crashes halfway through because they did an invalid input. So we talked a lot about user input checking as for making a better user experience with your tool, and this is one way you can do that. So you can, as soon as they give you a value, verify that it's a correct value that you can use. You can, when the tool is executing, provide them informational messages that let them know the tool is actually working, and you can have realistic progress bars that estimate the amount of time that things are going to take appropriately. So our full tool down here, just the execute function, which shows how the progress bar works. So we have the exact same information. We have start at 0, maximum value 100, step is 25, and then we have our how long the tool is going to wait, so 2.5 seconds. So the very first thing that we'll do before we run is set up our progress bar. So we set it with the minimum value, maximum value, and step value. We indicate that it's a step progress bar. Then we pause. So that way the user can see that we're checking building proximity. Now we add another message, and then we do some stuff. So we don't actually need this in here anymore because since our tool is valid, or since our tool has already validated that the building number a user entered is correct, we would be fine if we wanted to remove this checking again. Right, so all of this stuff that checks to make sure that a building exists by doing a where clause and a search cursor, and then checking to make sure that we get back a building from the database or from the feature layer. We already did that inside of the tool validation, so it would be totally fine to remove it here because we don't need it in two places. As long as we're sure that it's getting done in the validation, then we can rely on that and not need that down here. But in any case, we still have that code here. Now we can just see all the original stuff that we did before. Now we're adding messages, we're setting progress positions. So if we should proceed, which means that if the building that the person asked for is actually a building, we're going to set the buffer layer, then we're going to find our building, then we're going to do the buffering, then we're going to indicate that we are now a quarter more of the way done. We're going to add messages to the output, we're going to clip, we're going to indicate that we're a quarter more of the way done, we're going to add messages to the output, then we're going to do some cleanup to get rid of our temporary building, which we don't need anymore. Then we're going to set the progress position to be maximum, meaning 100% done. Then we're going to output some more messages. So you can see that these don't actually, all these things don't add like any functionality to our code. Our code does the exact same thing that it did. It's just making the user interface and the user experience more easy to understand. It double checks, does some idiot checks for the user to make sure they didn't enter some information into one of our form fields that we can't use, and then it also provides good feedback to the user, indicating to them that this thing is still running, we haven't crashed, have trust in us that we write good tools, and it allows them to estimate how long progress is going to take. So if you've ever installed a large program on your computer, particularly a Windows program, you've seen a progress bar lie to you. So try not to do that. If it's possible to estimate how long things are going to take, you should use a real estimation. And your progress bar should update in meaningful ways, not get all the way up to 99% real fast and then sit there on 99% for 10 minutes. So it's up to you how you define how long and what the progress is. So just use your brain and you'll be able to figure it out. Okay, so that's it. These are all user interface sprinkles that go on top of your already awesome code cake. So if you don't already have awesome code, adding these sprinkles on there isn't going to fix your broken code. This is just going to make it so that a user has a better experience working with your tools. So that's that. Enjoy.